Okay, in the first one, we're going to be graphing an absolute value function. So whenever you see these absolute value signs, we know that we're going to be having a V shape. Okay, so now we have to go ahead and talk about our different AH and K values and how our graph is being transformed or translated. So if I look at the A value, because I have a number that is less than 1, it is being compressed, meaning it's going to be a little bit wider. Okay. You can also think of our A value as like the slope of our lines coming off of the vertex. To figure out where our vertex is moving, we're going to look at our H and our K. So those two particular values, my H is a +3. Remember, that's going to move my graph in the opposite direction that you would initially think. So this is actually going to go to the left 3, and that -2 is going to move my graph down 2. So let's move our vertex first. It is normally at the origin at 0, 0, but we're counting it to the left 1, 2, 3, and down 2 spaces. So there is my new vertex. And from there, I'm going to follow my A value, my slope. So I'm going to rise 1, run 2. Rise 1, run 2. And since absolute value functions are symmetric about the vertex, I can go up 1 and over 2 in the opposite direction to get the other side of my V. So then I can go ahead and connect the dots to make sure I get the appropriate shape. Okay, let's look at g of x. G of x is a linear function because I have mx plus b. So m, -2/3, is going to be my slope. It's my rise over my run. And this +4 is going to be my y-intercept. Think of the y-intercept as like your starting position. So we're going to be starting at 4. And I am following a slope of -2. So I'm going down 2 over 3. 1, 2, 3. Down 2 over 1, 2, 3. Down 2 over 3. And if we want to go in the opposite direction, we go and follow the slope totally opposite. So instead of going down, we go up 2. Instead of going to the right, we go to the left 3. And then we have enough points to draw a straight line.